Dear students, hope you are staying well and fine. Welcome to the class of educational statistics again. And today I'll try to cover up one example of application number 4, which I left in my previous class, and applications 5 and 6. Okay, so kindly follow me. So it is the example number 2 for application number 4. Here you need to find out the number of individuals scoring below the score point 40. Here you need to use the formula, which is that Z is equal to X minus M divided by sigma, and you need to put the values in the formula and you will get the sigma score as minus 2.5 sigma. Okay, so now our work is to find the number of individuals or percentages of cases from the normal curve table. And for 2.5 sigma, the percentage of cases from the normal curve table that we will find is 4938 out of 10,000 or 49.38% cases. It means we have 49.38% cases lie between mean and minus 2.5 sigma. Now our work is to find out the number of individuals scoring below the score point 40. Here you need to subtract 49.38 from 50. As we all have the concept of 50, as we know that 50% cases lie on both the sides of the mean. So here we need to do is that 50 minus 49.38 is equal to 0.62% cases lie below the given score point, which is 40. Okay, got it? And here you can convert the percentage into a whole number or a round figure by doing like this. When you will do like this, when number of individuals will be given in your sums. But you have to remember that number of individuals will not be given in every sums. Okay, so you should not be confused for this thing. If number of individuals will be given in your sums, then you can do like this. You can convert the percentage of cases into round figure or the whole number. Here it is done like this. And what we found here is that 6 individuals in whole number achieve below the score point 40. Okay. So it is the example number 2 for application 4. Okay. And if I come to discuss the graphical representation here, then you can easily understand what is the graphical representation. What does it mean actually? So I would like to tell this thing. You see, it is the score point 40, and according to this sum, you need to find out number of individuals or percentage of cases scoring below 40. So when you will be asked to find out the percentage of cases below a particular point, then you need to go to this site. Okay, here what we did, we converted this raw score into sigma score, which we found as minus 2.5 sigma, and it is the position of minus 2.5 sigma. And then we found out the percentage of cases from the normal curve table, which we found as 49.38%. It means we have 49.38% cases from minus 2.5 sigma to mean. Okay, so it is the portion of 49.38%. 0.38% cases. Now our work is to find out the number of individuals lying below the score point 40. So what we did here is that we subtracted 49.38, this portion, from the whole area of 50%, as we all know about the 50% cases in the normal curve. Okay, so by subtracting 49.38% from 50%, we got the number of individuals or percentage of cases scoring below 40%. So, scoring below the score point 40. Okay, so this is the application number 4. This was the example number 2, which I discussed for the application number 4. I hope you are getting my point clear. So I am coming to the next application of normal probability curve, which is that number 5. According to number 5 application, normal probability curve is used to determine the limits of the scores. The limits may be upper limit and lower limit both, between which a certain percentage of the cases lie. You please listen carefully. It means we can find out both upper limit and lower limit in terms of scores, okay, between which certain percentage of individuals lie. Say for example, from the perspective of this application, we can find out two scores, both at upper limit and lower limit, between which 40% individuals lie. Say for example, I am just giving one example here. Okay, so I'll discuss this application with one example. Okay, so please listen carefully. This is the example for application number 5. Okay, so please follow me. If a distribution is normal with m is equal to 100, as d is equal to 20, then find out 2 points between which the middle 60% of the cases lie. Okay, before going to give the graphical presentation of the curve, we first need to understand that we need to do, or we need to distribute here the middle 60% cases into two halves or two parts, okay, which will be like that: 30% or 3,000 out of 10,000 cases to the left side of the mean and 30% to the right side of the mean. Understood? I hope you are getting my point clear. Before going for the solution of the problem, you need to divide the middle 60% cases into two parts or into two halves. One will be 30%, as we all know 30 plus 30 is equal to 60. So one will be 30% on the left side of the mean and one will be 30% on the right side of the mean. Okay. So now our work is to find the sigma score for 30% or 3,000 cases out of 10,000, okay, from the normal curve table. And what we found from the normal curve table, for 30% cases, the sigma value will be 0.84 sigma. Okay. Okay. So this will lie both to the sides of the mean, both at the positive side of the mean and both at the negative side of the mean. It means 0.84% will lie at the positive side, at the right side of the mean, as well as minus 0.84 sigma will lie at the negative side of the mean or at the left side of the mean. You have to be clear for this thing. Okay. So now here we need to find out two scores, 2 points, two raw scores. Okay, where middle 60% cases lie. So we have to find out two raw scores, and therefore we need to, put the values in the formula as we usually use the formula for computing or for transforming Z value into raw score or raw score into Z value. Okay, understood? Okay, so here we need to do like this. We need to put the values in the formula here, as we have two sides, both at the positive side, both at the negative side too. Okay, so we have to put the values like this way, and it is not 0.48, it is 0.84. Okay, so it is the thing, and by doing this, what we got here, we got the raw score as 116.8 and 83.2, and we can tell this as a whole number or round figure as 117 or 83, which include the middle 60% of the cases. And when I go to the normal curve and try to understand, it will be very easy to understand. I think you please have a look on this graph. You see, it is very simple to understand. It is 60%, and by dividing 60%, it will be 30% on the left side, on the negative side, and 30% on the right side, on the positive side. And by taking the sigma value from the normal curve table for 30% or 3,000 out of 10,000 cases, we got 0.84 sigma, both at the negative side as well as the positive side. And we used the formula of Z is equal to X minus M divided by sigma in order to find out two raw scores, both at the positive side as well as both at the negative side. And what we found here is that the raw scores are 117 and 83, within which 60% cases lie. I think you are getting this graphical representation clearly. Okay, so I am coming to discuss the next application of normal curve, which is, I think it will be application number 6. Okay, so please follow me, and having any confusion, you please text to me. Okay, so please see, it is application number 6. According to this 6 number application, normal probability curve is used to find out the limits in terms of scores which include the highest given percentages of the cases. Okay, here you need to find out limits. The limits may be upper limit as well as the lower limit in terms of scores, which actually cuts the highest percentage of cases of a particular group. Okay. Say for example, if I want to find out the upper or higher score and lower score, which is exactly related to the terms upper limit and lower limit in terms of scores of the top 5% of a particular class, we can use normal probability curve and we can show it. Okay. Generally, we use the terms like top 5% or top 10% in a particular class who are good achievers like this. Okay. Generally, we use these terms. So in order to find out the upper limit or the lower limit or upper score or lower score, we can use normal probability curve here. The upper score or the lower score can cut the top, percentage of individual of a particular group. I think you are getting my point here. So I'll show one example of this application. Here you see, given a normal distribution with a mean of 120 and SD of 25. So what limits will include the highest 10% of the distribution you find out? Okay, it means you find out the limits. It means you need to find out the upper limit which cuts the highest 10% of the distribution. It may be upper limit as well as the lower limit too. So please, let me go through the application. Okay, I think you need to find out the lower limit here, which cuts the highest 10% of the distribution, 10% of a particular group. Understood? Okay. So please follow me. Please go through what I discussed and what I am discussing. Okay. So here, what you need to do here is that you see here what you will do here. Okay. So it is given here that as we all know that 50% cases lie on both the sides of the mean. So here the highest 10% of the cases will have 40% of the cases between its lower limit, okay, and the mean of the distribution. It means now we need to find out the lower limit of the highest 10% of a particular group of individuals. And according to the perspective of normal curve, we have 40% of the cases between its lower limit and the mean of the distribution. And now we need to take the sigma value from the normal curve table for 40% of the cases or 4,000 out of 10,000 cases. Understood? Okay. Then what we got the sigma value here is that it is 1.28 sigma from the normal curve table for 40% or 4,000 cases. And here again you need to put the values in the formula which we usually take, which is that Z is equal to X minus M divided by sigma. So putting the values in the formula, as we have the sigma value here, but we need to find out the X value here. So by putting the values in the formula, what we got here is that 152 is the lower limit, okay, is the score actually at the lower limit of the highest 10% of the cases. 152 is the lower limit of the highest 10% of the individual of a particular group, and the upper limit of the highest 10% of the cases will be the highest score in the distribution which is not found out. Okay, so upper limit may be more upper, and upper limit will be the highest score in this distribution. Okay, so it is the example for application number 6, and now I would like to tell from the graph. You please follow me. You see, it is the point which cuts the highest 10% of the group. Okay, 10% of a particular group. Now, here, as I discussed you that this highest 10% will have 40% cases between its lower limit and mean. It is the 40% case. It is the lower limit of the highest 10% of the group. As you may all know that when we go to this side, it will be lower and lowest level of the distribution. And when we go to this side, it will be the upper side of the distribution of the according to the perspective of the normal curve. Understood? So it is the point which cuts the highest 10% of the group. Now we need to find out the point here. Point means it will be the lower score, lower limit. It is lower limit, and when we will go to this side, it will be the higher and highest scores of that particular group or of that particular distribution. Okay, so I hope you are getting my point clear here. Okay, so please try to understand, try to study carefully. I hope you can easily understand this thing. And that's all for today's discussion. And I'll come soon with the other applications of normal probability curve, as well as the other concepts like significance testing as well. Okay, so please stay at home and practice your reading. Okay, so thank you so much for today's class.